So it's a big day today when we finally learn the unit circle. So what the unit circle is a circle, obviously, with center 0, 0, and the radius is equal to 1. So what would be the equation of a circle with center 0, 0, and radius 1? You are right. X squared plus y squared equals 1 squared, or x squared plus y squared equals 1. That's the equation of the unit circle. So over here, we drew a circle with center 0, 0, and radius is equal to 1. So you might say, well, what's the big deal about the unit circle? This is the big reveal here. Any point on the unit circle is going to correspond to an angle, right? A theta, if you will, like that's the angle. And what we learn is that the x-coordinate of that ordered pair is the cosine of the angle, and the y-coordinate is the sine of the angle. X is the cosine, y is the sine. That's like a big deal, right? So if we just look at the first quadrant, if we kind of blow this up, like the first quadrant here with a radius of 1 here, and we look at the different angles, right? We're going to have 0 degrees, just of our special angles, a 30 degrees, a 45 degrees, a 60 degrees, and a 90 degrees. We're going to march around the circle and then talk about how we can figure out the ordered pair of each point. So if I just start with like a 0 degree angle, do you agree if the radius is 1 that the ordered pair is 1, 0? So that tells me is that the cosine of a 0 degree angle is 1 and the sine of a 0 degree angle is 0. The cosine is the x-coordinate, the sine is the y-coordinate. And my calculator even knows this. So if I type in cosine of a 0 degree angle, 1, sine of a 0 degree angle, 0. My calculator even knows. If we talk about a 30 degree angle, that's a little bit harder, right? So even though the radius is 1, that doesn't really tell me the x and y coordinate of that point, right, of a 30 degree angle. So what I'm going to do is drop a perpendicular down to the x-axis and then use my 30, 60, 90 rules. What is the side opposite the 30 if the hypotenuse is 1? You're right, a half. What is the side opposite the 60 if the hypotenuse is 1? Well, it would be 1/2 times the root 3, or square root of 3 over 2. So the ordered pair, or kind of the address of that point, is x comma y, root 3 over 2, comma 1/2. So what this tells me is that the cosine of a 30 degree angle is root 3 over 2, and the sine of a 30 degree angle is 1/2. And you might say, what happened to SOHCAHTOA? Well, it still works, right? Opposite over hypotenuse. Cosine adjacent over hypotenuse. The hypotenuse is just 1. So that's why the x-coordinate's the cosine, the y is the sine. If I go to a 45 degree angle here, so 45 degrees, hypotenuse is 1. If I want to find the x and y coordinates, I drop down a perpendicular. And then you would agree that each side here is going to be 1 divided by the square root of 2, which is the same thing as root 2 over 2. So the ordered pair that goes with that point, root 2 over 2, root 2 over 2. So the cos of a 45 is root 2 over 2. The sine of a 45 is root 2 over 2. And we knew that, right? So it all matches what we already knew. If I go on to a 60 degree angle, 60 degrees here, hypotenuse is 1. If I drop down my perpendicular, I get another 30, 60, 90 triangle. But now, of course, those two sides have kind of switched spots. The ordered pair, 1/2, comma, root 3 over 2. So the cos of a 60 is 1/2. The sine of a 60 is root 3 over 2. Nice when we get to a 90 degree angle, right? Because the radius rather is 1. There's no need to draw a right triangle. It's like the 0 degree angle there. We know the ordered pair is 0, 1. So the cos of a 90 is 0 and the sine of a 90 is 1. Perfect. So that's our first quadrant, the 30, the 45, the 60, the 90. And now we can take that information and extrapolate it to the whole family. So we're going to start with the 90-degree family, and I'm just going to do these in degrees for now, but we know we can do them in radians as well. The 90-degree family is 0, 90, 180, 270, aka 360. The nice thing about the 90-degree family is that radius of 1 is really all I need to get those ordered pairs. This ordered pair is 1, 0, as we talked about. 90 degrees, 0, 1. 180 degrees is -1, 0, and then 0, -1. So for each thing, we could say the cosine each angle, the cosine corresponds to the x-coordinate, the sine corresponds to the y-coordinate. So the cos of a 90 is 0, the sine of a 90 is 1. The cos of 180 is -1, the sine of 180 is 0. The cos of 270 is 0, and the sine of 270 is -1. Cos is the x, y is the sine. If we do the 30-degree family, right, we've already done 30 degrees. And I won't necessarily go through that whole rigmarole again with the triangle and everything. I'm just going to lift that ordered pair, √3/2, comma 1/2, to go with the 30-degree angle. The other angle in the 30-degree family is 150, 210, 330. Do we know what the ordered pairs would be for these other angles, knowing that ordered pair? You're right, and the -150, it would be -√3/2, comma 1/2. Here is going to be -√3/2, -1/2. And then +√3/2, -1/2. We take the same ordered pair, but the positive and negative signs just change. And then just to make my life a little easier, I'm just going to write underneath the cos and the sine. So this is saying that the cos of the 150 is -√3/2. The sine of the 150 is 1/2. The cos is -√3/2. The sine is -1/2. The cos is +√3/2. The sine is -1/2. Once we know the first quadrant angle, like in this case 60 degrees, and again we just talked about that on the previous page, how it's 1/2 comma √3/2, we can take that same ordered pair and essentially reflect it over the x-axis, -1/2 +√3/2, reflect it here, oops, it would be more here, 240, so -1/2 -√3/2. And then for 300 degrees would be +1/2 -√3/2. In each ordered pair, the x is the cosine, the y is the sine. The x is the cosine, the y is the sine. And I tend to like to write that out a little bit better, like say cos of a 300 is 1/2, sine of a 300 is -√3/2. But for ease of writing here, I just wrote it underneath. The final family is our 45-degree family, and that one's a little bit of an easier family, right? Because the x and the y coordinate are the same, √2/2, √2/2. So when I go to 135 and 225 and 315, the only thing that changes are the positive and negative signs. -√2/2, √2/2. -√2/2, -√2/2. +√2/2, -√2/2. And for each ordered pair, the x is the cos, the y is the sine. The x is the cos and the y is the sine. The x is the cos and the y is the sine. 45-degree family. So as one final wrap up here in the top, a lot of times I write just the coordinates in each quadrant. So in the first quadrant, it's always a positive x, a positive y. Second quadrant, -x, positive y. Third quadrant, of course, is both negative, and the fourth quadrant is a positive followed by a negative. And that is true for every family.